Welcome to the WindSim Technology Update webinar, a virtual user meeting for WindSim Americas region. My name is Donna Renemo. I am the president of WindSim Americas. Joining me today are Dr. Arne Gravdal, founder and chief technology officer, and Dr. Catherine Meisner, director of software development. Today we're going to cover the following topics. A brief introduction by Dr. Gravdal regarding the benefit of using WindSim technology solutions, followed by Dr. Meisner, who will demonstrate the new features included in WindSim version 8. Just to note that WindSim version 8 will be available for download from WindSim website this week. Dr. Gravdal will then follow with some descriptions of our wake modeling, cloud computing, and power forecasting solutions. And then we will conclude with Q&A or question and answer as time permits. Questions can be submitted via the chat window on your screens at any time during this presentation. We will respond to your questions if time permits during the conclusion of this webinar or via email after the webinar. This session is being recorded, so we will follow up for anyone that requests with a recorded link. We have some reasons for optimism. 2015 was a record year. Wind power supplied more new power generation than any other technology. China came in as the largest overall market, Europe second, and North America third, North America being comprised of Canada, Mexico, and the United States. 2016, Brazil joined the 10 gigawatt club. It's the most promising onshore market for wind energy in the region out to 2020. We're seeing new emerging markets in Latin America with total installed capacity of 12.2 gigawatts. Construction has been completed now in 2016 on the first commercial offshore wind project in the United States. Onshore wind power has become the least cost option when adding new capacity to the grid. Prices continue to fall, delivering electricity for 4 US cents per kilowatt hour. Given the urgency to cut CO2 emissions, clean our air, decrease reliance on imported fossil fuels, wind power's pivotal role in future energy supply is assured. Traditionally, WindSim holds user meetings yearly in Tønsberg, Norway, where our company is headquartered, and in Asia and the United States. These events include knowledge share amongst the WindSim users, important feedback from users regarding new product feature requests and enhancements, and of course fun. In Norway we sail mostly under this midnight sun. You see the picture there, and it's pretty awesome when the sun is shining at midnight. And then of course in Beijing, where we just concluded in China, where we just concluded the latest user meeting for Asia, we play ping pong. WindSim 2017 user meetings are planned as follows. For the WindSim Americas region, we will target May in tandem with the WIA conference that's taking place in Anaheim, California. And then for the Europe, Tønsberg, Norway in June, and then following in Asia and China in the fall. And all details will be available on the WindSim website. And with that, I'm going to hand this presentation over to Dr. Gravdal.
Thank you, Donna, and good morning, everyone. My name is Arne Gravdal, and before we kind of show you the new features of WindSim, which is the main idea with this webinar, I would just like to share some comments with you, and I would also like to ask you some questions about your current usage of WindSim. So allow me to start with this very well-known illustration showing the underperformance issue that was very, very bad for our industry some years ago. This plot actually shows more than 300 wind farms a year and the actual production versus the estimated production. And I'm sure that you are all well aware about this, that some years ago we had this issue with an underperformance in the order of 10%. Apparently this has been much improved. So this is another illustration, and here, as you can see, we have got rid of the bias. But still, there is something which we shouldn't be so satisfied about, and that is the spread. The spread is still very large. And we have also to ask ourselves, how did we get rid of this bias? And I will, to my understanding, some of these bias have been reduced according to more conservative estimates on the losses, and also due to using power curves which has been adjusted to each site. And an empirical adjustment of a power curve, that is something you can introduce if you don't really understand what's going on when it comes to the flow field over the swept area. That's if you don't have this knowledge, well, then you in a way can extract that knowledge afterwards in an empirical power curve. So I'm not sure if we should be totally satisfied. And my main point is that if we introduce better methods, then the picture should look like what you see here in my light blue illustration. We should have much less uncertainty. The spread should be much reduced. Okay, this was some years ago. This was a hot topic, but I would like to remind you that we should keep an eye on this still today. Some years later, the industry gathered again and tried to look into this in a bit a different way. Here, these illustrations show the actual versus the expected production along the y-axis. So if you are above 100, it's the production actually was higher than expected, and below 100, it's lower than expected. And along the x-axis, it is the uncertainty. And of course, what we should expect is that if the uncertainty increases, we should also have larger spread in the actual versus expected production. But this is something we don't see. So then we have to question ourselves, why don't we see this trend that everyone would expect, that with higher uncertainty, you will also have higher variation on the actual versus expected production. So I think still that that we have to work on better understanding the flow condition over the swept area. Okay, that was my comments, and then, as I said, I have a few questions. And the first one is simply, do you use WindSim in simple terrain? Most people don't use WindSim in simple terrain because originally it was a tool. But I would like to remind you that if you have an offshore wind farm, then actually everything is set by the conditions at the border, and you will have the solution in rod iteration. That is how WindSim will work. So of course you can do more complex thing in the inner as well, in the inner domain, but basically that is how it will work. So it means that to solve for simple terrain is extremely fast. So what most people hold as a penalty against safety is not at all valid when it comes to simple sites. And then just to remember one thing, if you use WindSim for simple sites, then you have to be aware that the conditions at the top border has to be changed. We have a default condition, which is the so-called fixed pressure condition, and this will not work if you have a flat terrain. So then you have to also set boundary conditions at the top, which is the fixed wall. This is just a reminder, and here is an illustration that shows why this is the case. I will not go into any details explaining this, but I will just remind you about this. Then one more slide on simple terrain. Well, simple terrain doesn't mean a simple flow field. Here is an illustration showing a flat area, incoming wind passing over a forest. It decreases the wind speed, a boundary layer is developing, increasing wind speed over the open area again, a new boundary layer develops, and so on. Every time you have a shift, a boundary layer develops. And then the question is, okay, what kind of profile do you have over the swept area? This is also a simple illustration showing the rule of thumb that the influence area for a 100 meter swept area is in the order of 1 kilometer. So if you have a very stable stratification, for instance, maybe this is not mixed out, so you will actually see also a profile that holds a fingerprint from these changes in roughness. So even a simple flat case can develop a complex flow field. And then I've heard stories over and over again during these years, and first time I heard this story about some surprising observation was when I visited New Zealand many years ago. The largest wind farm in New Zealand is Tararua, and there the wind farm owner told me that they actually saw the highest production on the lee side. Turbines standing on the lee side had the highest production. And then I've heard this over and over again, and quite recently I also heard it from a wind farm owner in Norway that planned a wind farm. They had some location, some area available on the lee side of the mountain, and they considered to skip the turbines there, but at the end they actually installed turbines also where they expected to see low production, but it is among the best producing wind turbines which are standing right there on the lee side. And of course, this is a very simple explanation of this fact, and that is related to stability. This is a work done by WindSim. It's a study at the University in Edinburgh showing stratification hitting an obstacle, here a small cosine hill, and then a gravity wave develops. So you will see the highest wind speed on the lee side of this mountain. So this has been available in WindSim for I don't remember how many years, but I think that not so many users actually try to activate this and try to understand if stratification is important at their site. So the question is, do you use stability? I will say that if you have various wind measurements, and if you see that the directional shifts that you find in your measurements are not correctly reproduced, that you see typically less directional shifts in the flow simulations compared with in the measurements, then that could be an indication that stability is part of your problem. Stable flow will typically show larger directional shifts. Then I just would like to remind you about the cross-checking and our so-called validation program that we introduced in WindSim 7. As soon as you have more than one metmast represented by time histories, it's possible to do a cross-checking, and I'm sure that this is what you do. And what we decided some years ago was to ask for permission to obtain this data in an anonymous way. I must admit, we don't know fully, we don't understand fully how valuable this will be for us, because it will obviously be difficult for us to know what kind of quality you put into your measurements, what kind of quality you put when you set up your model. But there are some more information that we extract, and hopefully we'll be able to deduce something about the quality of your simulation as well. But this is anyway our long-term plan, to be able to classify according to terrain complexity the cross-prediction error. And I would also like to show you one example, because every now and then we get input from our users, and this was a user that had this case. We have been allowed to share it with you, and it's a relatively small model. It's typically a model we run during a lunch break. As you can see, it's only 300,000 cells, and then it's a simulation that takes 6 minutes to run. But it's so interesting to look at, because here there are two metmasts. They are 3 kilometers apart, but the change in wind direction and in wind speed are remarkable. Since it's only a 300,000 cell model, I will also ask the question whether you check for grid independency and whether you check for boundary condition independency when you do your runs. It might be that a lot of people run much too large models, that actually they don't really get any improved results by running these tens of millions of cells. But I'm not sure about that. But this is for sure something to keep an eye on. At least with this relatively coarse model, we were capable of capturing in this cross-checking procedure what's happening between these two met masts. As you can see, position 1, wind from west. Position 2, it's shifted towards north. This we also see in the flow field. But the most important, we have a significant reduction in wind speed in the order of 2 meters per second. And this is also very, very nicely captured in the cross-checking procedure. And just to show you, I mean, the consequences would be obvious. If I try to arbitrarily put out turbines along the ridge where a measurement mast is situated, it could be like this. This is just more or less uniformly distributed. But look at the large, enormous variation, I would say, in wind speeds, as you can see over the steppe areas. And I just remind you, these things you know, 6 meters per second will give you a production of 370 kilowatt for a 2 megawatt turbine, whereas if you can rise it to 8 meters per second, then you rise, of course, the production enormously up to 900 kilowatt. Okay, this is today our software suite, but I will not comment in particular on that. But this is also a plot that I usually show. It's very simple. It shows the value of using accurate flow modeling. So here is a sketch showing the potential income from a wind farm. You have your capital expenses. You have to pay back your loan to the bank. Hopefully after some years it's paid back. You have your operational expenses, which most likely will increase year by year. And then here at the top you have your income from the production. Here it will also vary year by year, but for simplicity I've just given it as the mean here. So the profit is within this blue area. So if you do accurate flow calculation, if you do well done measurement campaign, then you have the possibility to increase the AEP by park optimization. You will avoid the dangerous areas where the turbines will be have a reduced lifetime, so you will reduce the operational cost. And you will also go to the bank with less uncertainty, and it will give you a better financing. So of course you gain on all sides here. And we know that this is your daily work, but I would very, very much like you to share this information with us. I mean, every now and then you might try to estimate in dollars how much value do you actually bring to the projects. And if you have this information, that would be very, very good if you could share that with us. I mean, we have the same troubles every day, and we would be stronger if we could bring up real good evidence of the value we bring to this industry. A look into the future. This is not really the future in the sense that this is a simulation that was done back in year 2000. But it's done with WindSim. It's done with changing boundary conditions. We can of course do transient simulation in WindSim. And the question is that in the years to come, should we start doing transient simulation? Will this bring you any value? Will it be beneficial for the production, for the loads, as we have done in the pre-construction phase? If we could do this real time, along when the wind farm is running, would this give you any value? These questions we ask ourselves. We think it will bring value. We think we are heading in this direction, but here we would also very, very much like your input. Okay, that's the end of my part. Then I bring it over to you, Katrina. Let me see if I can stop sharing my screen and hand it over to you. Okay, you should be the presenter now.
Yes, I hope you can see my screen. Welcome to our webinar. I have the pleasure to present you today our recent developments in WindSim. I will start with an introduction, what we have done in WindSim 8, and then I will go on with some validation work and talk about our ongoing research projects, and then I will describe the way forward, what we want to develop in WindSim in the future.
Katrina, are you in full screen mode?
No, because I know almost, but I will go to the software at once, so then I will go out anyway. We have a lot of new functionalities, and the first thing I want to mention is the reduction in size of the projects by using a new zipping program and by using binary files. So we have reduced the WinField folder size by about half. And you can choose this new setting under the advanced settings on the top of the program. We have also a new functionality which is called the run in batch mode. This has been here for several years and in several versions, but now when you activate this run in batch mode, we will go directly to our new queuing system. And also important for the WinField calculation, we have improved the speed of the parallel solver in this version. So now you can really gain, if you have large models, to split this on several cores. I want to demonstrate this in the program. So here under the settings, the advanced settings, you can choose if you want to run in binary mode or in ASCII mode. So the binary mode is very good to compress the file size, but if you want to read the fee files in the end, then you should choose the ASCII format here. This format will then be kept for all your simulations. I just want to demonstrate now how the batch mode is working. So if I put here the run in batch mode to true, and I have put 4 sectors at the same time, then I will start the queuing, and you will see that the project is directly put into a queuing system. You can look at the single sectors, so we start one sector after the other, so we will run in total 4 sectors at the same time. They will be started a bit with time delay, such that the computer is not overloaded. On the left hand side you can see the settings which are automatically done, so we have 4 parallel sectors, and we allow WindSim also to manage the number of parallel sectors in accordance with the capacity of the PC. Below here you see the dashboard, which is showing you several things. On the left hand side you can see the RAM usage, so you can see how occupied the PC is, and on the lower side you can see the disk usage. So here you see that my PC is almost full, and I also get the state the disk warning. In this case this is not so tragically, because it's only a small model which I'm running, but this would warn me in advance if I would, for example, start a big simulation and would not have enough space for it. Then I can also select the amount of licenses I want to use for the simulations. So here in this case I have a quad-core license, so I have 4 different licenses, and I could even select several licenses to go into this queuing system, such that 1 or 2 licenses stay free, which I could use during the normal working time. If you follow on the right hand side, then we can see now that the first sector has already completed. The other 3 are still running and are about to complete. You can at any time pause the simulation so that you can resume it later, or you can stop it, or you can even say, okay, I don't want to have this simulation anymore, and look at the details. If you look into the results which are produced now, so this is the WinField folder of that project, you can see that we have not longer the fee files, but so-called feeder files. This is then the binary format, and you can see that here we use the 7-zip for the zipping program. So if you go back to the presentation, another new functionality is the export of the VTF files, which can be done for all sectors now with 1 click. This is just to fasten up your post-processing. We have given out more information in the text file in the export to ASCII format. We have the overall shear and inflow angle weighted by direction in this file now. And we have also improved the export to WASP with less memory consumption when doing the weighted wind resource map for a regular grid. I also want to show you this directly in the software. So if you go to the wind resource module, then here many people are not aware that we export this ASCII file. If you open this ASCII file, you can get the X, Y, and Z coordinate, and then the mean annual wind speed, the mean turbulent intensity for weighted over all the sectors, and the same now for the inflow angle and the wind shear exponent as well. And here in the export to WASP, we can then also select the type of export if you want to export for the complete grid, the refinement area, or a user-defined area. The next feature which we have implemented is that the reanalysis data downloader has the MERA2 data now. This I also want to show in the software. Let's have to close the queuing. So if you go to Tools and then we search the reanalysis data downloader and we open this up, then we can see that now we have two choices, because we had the MERA dataset which was produced until beginning of this year, and then the MERA dataset was stopped and they produced a new dataset which is supposed to be better, which is called the MERA2 dataset. So for the year 2016 only data for MERA2 is available. I just want to demonstrate the download and also show you what you can gain from it. So usually here you can download your time series for the period you are interested in. You can also say that he should load more than one file at the same time, and then you can start the download on the right hand side. What he's doing then is that you have given here the climatology position, and he will then search the 4 closest MERA data points to this climatology. So here you can see these green points, and he will download this data and automatically convert this to a TWS file. So if you look into the C folder where the data is stored, then you can see here the downloaded files, and you can see the TWS files which are created 1 to 4. 1 is the closest MERA data point to the climatology, and 4 is the point which is farthest away. And then we have also the text file here, which gives you information about further parameters. So for example, important in the end here, you have the Mon and Obukhov lengths, which tells you something about the stability conditions on your site. So here you can assess if you should consider thermal effects in your simulations. Another new feature are the lookup table export for forecasting. So here we take a CFD project and we automatically export all necessary information which we need to do forecasting based on CFD. So this means that every WindSim user is able to make a wind power forecast based on CFD in our WindSim web portal, and Arne will talk a bit more about this later. Another nice functionality is the reference wind speed calculation for less than 2 years of data, because this is always, if you want to do an IC classification, you need the VREF, and that's always a problem to get this when you have less than 2 years of data, because normally we fit a variable distribution to the peak of the wind speeds, but of course if you have only a few data sets, that is not so easy. We use here the EWTS2 algorithm, and this is a method for extreme wind speed estimation that appeared in the European Wind Turbine Standards too. This algorithm is unique as it does not consider any of the peak wind speeds recorded in the time series data, and the only information it requires from the measured dataset is the mean wind speed and the variable K value. And the theoretical formula is given here below. So we will apply this automatically all the time when you enter with a time series of less than 2 years. We have also improved the grid reporting. We have included forest pictures and also all wind resource maps if you have several climatologies in your projects, and we have also made the Chinese grid report. Also for the park optimizer, we have a new version. It has the characteristic turbulence and effective turbulence maps according to the IC 3rd edition. With the turbulence maps, they can be generated for range of wind speed winds, and we have several options for turbulence extrapolation. We can do this from CFD results, from the mast, or from a combination of CFD and mast. The optimization is we added the elliptic distance constraints, and then we have the advanced optimization available through a wind farm designs cloud service. We have the energy maps with density correction now, and we have also icing correction. We allow now for 12, 16 or 24 sectors from WindSim results. The release date for the WindSim 8 version is on Monday next week. A bit about the validation work which we have done. We are very interested, of course, in forest validation. We have a master thesis at the moment about the general behavior of the forest model for idealized cases, and we test different forest models than the one implemented in WindSim now, and this thesis will be available soon on our webpage. We have done a real-world validation on 2 large sites from E.ON in Sweden with up to 7 or 8 metmasts per site, and this has been an oral presentation at the Wind Europe conference this year, and this can be found on our webpage as well. The title is Validation of CFD-based forest modeling for large forested areas with many measurement masts. The results we found was that good vegetation data reduces the errors, and the careful forest modeling around the metmast is key for a successful CFD run. And using atmospheric stability information from mesoscale models improves the shear profiles. And here we go back to the mirror data downloader, which can help you to find out a bit about the atmospheric stability on your site. We are still doing some work here, and is planned to have to focus more on the turbulence now for the coming months. We have also created the wind atlas method in WindSim. This has been developed together with MeteorTest, as they had the task to produce a wind atlas for Switzerland, which is really complex terrain. So here we have run 14 WindSim simulations for complete Switzerland, and we have combined the results together as one large wind map, and then we have scaled those results against 200 available climatologies, and the outcome can be seen on this web page. It's the wind speed and the variable parameters over complete Switzerland for different heights. We are also very active in dynamic line rating. We had poster presentations together with Idaho National Lab and the Department of Energy at the Wind Europe conference this year, and they are also available on our webpage. We have also a lot of ongoing research projects. We have 2 main research areas, the mesoscale coupling and the machine learning techniques for nowcasting. About the mesoscale coupling, this exists in WindSim since 2009, but this has often only been used by universities. Since last year, the interest, especially from turbine manufacturers, has increased to get a good commercial product, and we have developed the WRF to WindSim converter, as WRF is the most common used mesoscale model. We are running validation studies to improve this direct coupling and to see the added value compared to the default WindSim simulations. Here the goal is also to include transient simulations, and the validation is done on one site in Sweden, which is provided by E.ON, where we have 1 year of mesoscale model data and 6 measurement masts. We are also active in the field of machine learning techniques for nowcasting, because WindSim is also since 2009 active in wind power forecasting. So far the focus has often been on the day ahead, but now we want to look more for the next hours, and for such forecasts we have to base the methods more on statistical methods than on modeling. And here we have also had a poster presentation and an oral presentation, which you can find on our webpage. The way forward, what we plan to do in the next year, the general features we want to introduce is a Google Earth export of WindSim results. We want to compress all the VTF files in binary format to reduce the project size even more. We want to improve folder management and want to have a new 3D visualization component from Citron, which will replace the GLView and Innova, which is used today. We also plan to have new hardware or software keys. Regarding the CFD in the WindSim modules, we plan a faster post-processing and scaled vertical profiles. So if you know the flow model verifier from Windographer, where you can compare CFD results to measurements, we will provide something similar, but even better, because we will also do comparison of turbulent profiles with measurements. And then we will have climatologies with thermal stability information and climatologies weighting based on trust. We plan also to output in the Flowers format from WASP. This is a new format in WASP, which should be better than just the Weibull parameters in the WRG or RSF file, which they have today. And we are searching people who want to test this format when we create it from WindSim. But it's also really up to you. So what do you want to see in WindSim? You are invited to write to us at features@windsim.com and let us know your needs and what you think WindSim 9 should contain. And by this I will end my presentation and hand back to Arne Grafstad.
So the first slide here is CFD versus analytical wake models. As you know, it's the analytical wake models that is in common use in the industry, and it's clear it requires very little computational resources, and of course they are tuned so they describe very well what's happening in the far field after one single turbine in a flat terrain. So of course the problem starts when we have more than one turbine. So we look at wake-wake interaction when we have not a flat terrain anymore, but the wake terrain interaction, and of course also when we have more problematic atmospheric conditions with high level of turbulence stability, then it's semi-empirical how the wake will spread according to these analytical wake models. But in WindSim we have three, and they are the one commonly used in the industry. But we have for many years tried to develop a wake model based on CFD, and our approach has been the actuated disk. So with the actuated disk we try to represent the rotor itself with a porous disk which will have the same characteristics as you will obtain due to the three blades behind the rotor. So hopefully then the wake expansion will be based on physics, the wake terrain interaction will be based on physics, but and also the turbulent characteristics. But the drawback is of course that it will require much more computational resources. So this was a big penalty some years ago. We feel that maybe it's not really that big penalty today with the resources we have available. So if you take it one step forward, Donna. So this actuated disk has been available in WindSim for quite long. So you can also run it in WindSim version 7. Then you go to the terrain module, and under the refinement there is an option to activate the actuator disk. What is happening then is that there is an associated object file which contains the location of each of the turbine, and based on this we create a grid where each of the turbine is represented by this porous disk. One more, Donna. So here is then an example of the effect. You also have, this is just to explain you how we have been developing this and what kind of research we have done in the past. So one of the first questions you ask yourself is, of course, you take and make a porous disk, and you say that this should represent 3 blades, and of course it's not exactly the same. So also, how is the thrust applied over the rotor length? We could have different formulas, and this is our first test. We say that it's uniformly distributed, and then we give the distribution according to different profiles. But luckily, if you look at the right side here of this figure, then you see the wind speed. And I've also indicated that if you go some rotor diameter downstreams, and again, of course, this is a wake model that is not supposed to be correct up to the rotor. That's not our target. But we would like to have it correct where the next turbine is standing. So in this situation, I look at the conditions 5 rotor diameter downstreams, and you see that here the conditions are pretty similar in all the 3 cases. So it's not that much dependent on how we actually put the forces up on this disc. And that's, of course, a great advantage for us. Next, Donna. Yeah, and this is then an example. One of the WindSim users, Professor Francesco Castellani at the University of Perugia, he came to the user meeting in 2003 and showed how he have used this also then in a complex site. So this is just an isosurface of the wind speed. So this is the low wind speed region, and here you can see along the ridge all the turbines, and you see how the wake more or less follows the terrain. So here you have an example of a wake terrain interaction that normal models will not be able to capture. Next. Okay, so this has been there for quite some years. Now we have an industrial PhD, which have been working on further refinement of this technique for the last 3 years. He's about to finish his PhD, and he will implement his findings in WindSim. So then it's very, very much about user-friendliness, about to calculate this in a more efficient manner, so that we don't would like to have this limitation that we cannot run the whole wind farm. We can only run a few number of turbines because the computational resources were so demanding in the past. We think that we have improved a lot, and hopefully we will be able to do these calculations with the same type of input as you have in your current wake modeling using the analytical formulas. Yeah, and then if you take one more, then it's just a reference list, and that's if you step one forward, Donna. So here is just the existing analytical models, and then these are 3 of the validation cases that this industrial PhD have done. Okay, that's about the wake modeling. Then I have a few slides about cloud computing. Why? Well, it's obvious. We don't necessarily have the available resources under our desk. On the WindSim website, you will find our recommendation for what resources is required. And of course, you all know this. It's better off if you have a fast CPU and a lot of memory. If you take it one more, Donna. We have this important rule of thumb that we will need 1 gigabyte of RAM to handle a model of 1 million cells. So as an example, if you are located somewhere where you typically use 16 sectors, then you can create a 8 million cell model, and you can run all the 16 sectors at the same time if you have a computer with 828 gigabyte of RAM. And a lot of you have that, but not all. And then it could be an option to do calculations in the cloud. One more, Donna. So what is the cloud? Well, it's a network of servers spread across the globe. There are many companies that offers cloud computing: Google, Microsoft, Amazon. Our programmer found this number. It's not updated. I don't know how many servers there are around today. But anyway, we use the cloud from Microsoft called Azure. And on the lower left, you find the data centers of Azure. And each data center contains a lot of containers. And inside these containers, there are then an enormous amount of computers. So it's, of course, flexible. And very, very powerful. The next. So how have we used the cloud in the past? Well, we actually introduced the cloud computing also some years ago with our simplified version of WindSim called WindSim Express. We know that a lot of existing WindSim users use Express a lot to set up the projects in an easy way. But in principle, you can also do the calculations in the cloud. But what we allow with Express is just to download a report. That is the only output you get. A report on wind resource assessment and then an estimate of the AEP. Today, we have also introduced WindSim Cloud for existing users that would like to run their complete project and download the complete project for further post-processing locally. And Katrine told about our efforts in trying to reduce the amount of data by simply doing it by using binary files. And this is very, very much linked with our efforts in doing the cloud computing more efficient. Because we know we have the computing resources, but if it takes hours and hours to download the projects afterwards, then it wouldn't be a successful service. So this is what we are working on to reduce the project size as well. In the cloud, there are so many types of computers you can access, but we have standardized on one quite powerful computer. It is a computer with 20 cores and 140 gigabyte of RAM. And at the moment, it's a manual setup. It means that you contact us and you can rent this computer per day, and it's a €100 fee per day. And then we also charge a 100 setup fee to upload licenses and prepare the computer for you. This is as opposed to the WindSim Express, where everything was automatic. There was online payment, and you paid for a certain number of reports, and there was no kind of communication with WindSim. But for WindSim Cloud at the moment, you need to contact us, and then we will set up this powerful computer for you. The next one, Donna. This is the very end, and it's about power forecasting. This contains a lot of text. I don't expect you to read it, but the figure here illustrates the typical energy mix in many markets. So electricity is produced by wind and solar, nuclear, coal, gas, oil, and all these have different operational costs. And according to the demand, you kind of start these different sources. And what will happen when you have a large penetration of wind and solar, variable resources, then of course you will also have a very, very large variability in the pricing. And this is kind of what we see in many markets now, and that this is the underlying reason why we look at power forecasting. And on the short term, that's very important to notice that this is our main interest in. It is in the really short-term forecasting. So if you go one step forward, Donna. So short-term for us, it could mean 50 minutes, because we know that in Europe at least, the imbalance market is traded every 15 minutes. And if it's on that scale, then of course we understand that the meteorological model will have less value, whereas information about the status of each turbine, that will be important. And also then statistical methods, artificial neural network, and a physical model on the micro scale will be the things that bring value. The next one. Yeah, you can go one step further and even one. So this is the typical scales, and this you have you know the global models, the meso models. But my comment here is that typically it has been statistical models that have been used to go from the mesoscale down to the microscale, because it's a huge step. It's typically much larger, the step from mesoscale down to microscale, than the steps the meteorologists have been able to kind of go with physical model from one step to the next. Whereas we have a huge challenge, but I believe that this big step, these many steps in scale will be bridged with physical models as well. But at the moment it's mostly done with statistics. But of course it's our aim to see the combination of both statistical models and physical models on the microscale. So if you take it one more, Donna. So this is just some examples. Here in the middle, you see how we try to bridge the gap between the large scale or the mesoscale and the microscale with artificial neural network. Here we train against what we obtain from the numerical weather prediction model and what we obtain of production on each turbine. So here we have a so-called artificial neural network from wind to power. But on the right side, we also bridge this gap between the large scale and the small scale with artificial neural network. But here we look at wind to wind. So we look at the conditions at a single measurement mast. And then we transfer it out to each turbine by using CFD. So here it's a combination, both statistics and physical modeling. And you can take it one step further with another step with artificial neural network from the turbine level to the production level. So you can also do power to power with an artificial neural network in the next step. Okay, Donna, one step further. I see that time is limited. This is to kind of explain all the various setups. This small figure showed you some strategies, but there are many strategies you can set up depending on what you have of available data, both of historical data and online data. So the only comment to this plot is that in order to do this in an efficient way, we need to do the heavy CFD calculations in a set of period. So this is pre-calculated, and this is what Catherine showed you as well. You have your WindSim project, and you can simply create a lookup table which contain the relation between a measurement mast and each turbine. And then you can use this in the forecasting mode, and it will be very fast. So then it will work also for forecasting to use a CFD model. So the next, Donna. Yeah, and during these years we have taken part in many, well, internally we call them beauty contests. You have to kind of prove that you do accurate forecasting. So every now and then we take part in benchmarking. And this was a very large one. It went over 6 months. It was 10 wind farms spread around in Europe, 1,000 megawatt. And here you see our results against 16 participants. And this is a case where we didn't use CFD, but we use artificial neural network for all except one wind farm actually. And we were very satisfied with the performance in this case. So one step further, an illustration of how you can also combine. As I said, here we see the value. We use artificial neural network, and it works well in the mean range of output. But the extreme events, when you have full production, then the artificial neural network tends to smooth out. So we see that the CFD hits better when you have full production. And then it would be pretty simple to create some rules saying that over a certain threshold you use this strategy, and below this threshold you use another one. So this is what we try to look into, hybrid strategies. One step further, yeah, hybrid solution. So we can offer this now, and we can serve you by sending you this on an FTP server, but we also allow you to simply access our portal, and we can configure on the portal, or you can do it on your own. And we will also deliver our technology through so-called wind farm management systems, and we have integrated it towards several of the existing wind farm management systems in the market today. Then I believe it's a last slide, Donna, and this is the login page on our portal. Here is the address, and we would of course be pleased if you contact us and ask for a demo user, and then you can explore to run our various strategies and to set up. You can even do the artificial neural network training here, and you can export the CFD lookup table, and you can activate the various types of power forecasting strategies. Yes, I believe that's the end. Then I hand it over to you again, Donna.
Okay. So thank you very much, Arne and Catherine. We are very close to the 60-minute mark. So what I would like to propose is that we answer via email after this presentation the answers to your questions. I'd like to bring to everyone's attention that we are running a promotion, if I may, between now and the end of the year, offering 30% discount off the commercial license prices. Any technical questions for all of you that are WindSim users could be sent to support@windsim.com. I hope to see many of you from this region in Anaheim in tandem with the WIA exhibition. We will be having a WindSim Americas user meeting, which we will include training and then also welcome presentations from various users. And with that, we're going to conclude. For all of those Americans online, happy Thanksgiving next week. Happy holidays. Be safe. And I thank everyone for joining today.